Optics contains a lot of information, so I'm going to get through much of it as I can. First thing to note is with the drawings. You will not be asked to actually do the drawings, but you will see setups for drawings and then have to know how to handle them. In all the drawing cases, you'll be given an object already drawn on there as well as the focal point already drawn on it. From there, you'll have to do the rest. Now, it doesn't matter what type of apparatus you're looking at. There's always a line that goes parallel. And then after it goes parallel, it goes through the focal point. So, if we look at this first one, parallel through the focus. The second one, parallel through the focus. The third one, parallel through the focus. The fourth one, parallel through the focus. I know that some of these are supposed to be dotted and some of them are going to reflect back, but don't worry. It's not going to matter because this is a multiple choice test and it won't be marked down if you make something dotted or make something solid in the wrong place. If we're talking about lenses, lenses are great because there's always a middle line. Middle. Second one, through the middle. Now, we can see that there's an intersection right here at the bottom one. That's where our image is going to be. These two lines, based on my drawing, are coming too close. If they intersect down here, the image would form over there. If not, you would just trace it back and it will intersect over there. If we go back to mirrors now, there's always a line from the focal point, then that goes parallel afterwards. So, our second line, through the focus and then parallel, there's our image. Through the focus, but when you hit the mirror, you have to stop and then go parallel. Image will form here. Key thing to note is for every single mirror drawing, based on the type of setup that we have used, for mirrors, your image is always going to form either here or here. If it's a lens, your image will always form here or here. For mirror, it's impossible to form an image here or here, and for lens, it's impossible to form an image here or here. Next thing to talk about in optics is what's called magnification. Magnification can tell you a tremendous amount of information about the actual image. For example, if magnification is positive, then it has to be virtual, and therefore it has to be upright. If it's negative, that has to be inverted, and therefore it has to be real. If the magnification is greater than 1, that means that the image is bigger than the object. If the magnification is less than 1, that means it's smaller than the object. But do keep in mind we are talking about the absolute values of the magnification, not just the magnification number itself. So for example, if your magnification is -3, it is still big. Next thing in optics deals with Snell's law. In particular, the exam is going to focus on how the light rays will bend. As a light ray approaches, let's say it has a boundary between air and water, there will be a little bit of the beam that will reflect this way. Based on the law of reflection, this angle here, theta I, has to equal this angle, theta R, that has been reflected. That's not Snell's law, that's just a property of all things that reflect. Since water has a higher index than air of 1.3 and air is 1.0, the light ray is going to bend towards the normal based on its original path. If, on the other hand, it was the opposite, where you had something like glass of an index of 1.5 placed on oil of an index of 1.4, as the beam came in, it will actually bend away from the normal. This allows for a chance for a critical angle. A critical angle happens only when you go from a high index to a low index. It cannot happen the other way around. What will happen when the critical angle hits, instead of going through the material, it will reflect back. It will follow the law of reflection as for what the angle will be. But again, it will only happen if you go from a high index to a low index. The equation for it is the inverse sine of N2 over N1. If you punch N2 over N1 and then take the inverse sine of it and it comes out air, that means you can't have a critical angle that way. For example, the inverse sine of 1.5 over 1 is not possible. Therefore, you cannot have a critical angle from air going into glass. If you have a critical angle that does happen, that is the minimum angle it needs to be. There can be critical angles that are bigger than that.